Okay, so good morning everyone. So today's lecture we are going to discuss about programmable logic devices. Okay, so shortly we will be calling this as programmable logic devices. So shortly we will be calling this as PLDs. Okay, so what is called as this logic devices and the two programmable logic devices. Already we heard about what is called as logic gates. Okay, so logic gates means it may be either a NOT gate or AND gate or OR gate, etc. XOR gate, exclusive NOR gate, etc. So here, instead of talking about a simple logic gates, I am going to talk in a form of array. Okay, here that is group of AND gates. That is group of AND gates. Group of AND gates or group of OR gates. Okay, that is group of AND gates or OR gates. So such that they are called as array of gates. Okay, so when there is a combination of array of gates, that will be forming this as a logic gates. So the next term is called as programmable. So what is called as this programmable? So programmable denotes that I can change the value of your inputs. Okay, that is changing the value of your input. Changing the value of the input. So sometimes the input may get fixed. For example, if I take your AND gate, this is a simple AND gate, I can fix both the inputs to directly to the ground, or I can connect both your inputs to a direct a fixed VDD. So these are nothing but your fixed input supplies where I cannot able to change my inputs. But there may be a possibility in some combinational or sequential circuit where we can change your inputs. Okay, so that is called as programming. So generally we will be denoting your programmed by this cross mark. Sometimes they will be calling this as a fuse, or sometimes they will be calling this as programmable. So in the array of AND gates or OR gates, if I am able to program, then that will be called as programmable logic gates. So in our programmable logic gates, that is PLDs. Okay, in our programmable logic gates PLDs, there are three types. Okay, one is here PROM, PROM, another is PLA, another is PAL. So what this PROM? So PROM stands for programmable read only memory. Okay, PROM stands for programmable read only memory, and PLA stands for programmable logic array. Programmable logic array, and your PAL stands for programmable array logic. Programmable array logic. So you want to know what is the difference between these three type. Okay, so I told you we will be having a combination of AND array and OR array. Okay, we will be having a combination of AND array and OR array in all these programmable logic devices. So if you see, these logic devices will be having a combination of one AND array and OR array. So the first will be one AND array, okay, and the second will be one OR array. So either it may be either a PROM or PLA or your PAL, all will be having the same combination. Okay, it will be having a combination of AND array and OR array. One is here AND array and another is here OR array. Okay, so for the PAL also I am going with the same combination AND array and OR array. But what is the difference in these things? So when I talk about this PAL, all your AND array is also programmable and your OR array is also programmable. Got it? So both your AND and OR are programmable here. When you talk about this PAL, programmable array logic, only your AND gate is programmable, whereas your OR gate is OR array is fixed condition. Okay, only your AND array is programmable, OR array is in fixed condition. If you talk about your PROM, in your PROM, your AND array is fixed, whereas your OR array is programmable. Okay, so this is the difference between all these three types: programmable read-only memory, programmable logic array, and programmable array logic. Now we want to see how to implement, that is how to implement any circuit. Okay, that is how to implement any equation or any circuit, okay, using this PAL or PLA. Here we are not going to focus on your PROM, okay, just I am going to focus on your PAL and PLA. If any expression is given, that is if any one output expression is given, how you will implement this particular expression using PAL and PLA. First I will take one simple example, a simple expression. For example, F1 equal to A bar B plus ABC plus A dash B C dash, okay, and F2 equal to same A bar B plus BC plus A bar C bar. Okay, so this is a simple expression that is given to you, and for example if you want to implement this expression using PAL and PLA, how to implement? So what is the first step in implementing this expression? So first step is we want to check the number of variables. Okay, we want to check the number of variables. How many variables are there? We want to check it. And your second step is we want to check the number of terms. Okay, second step is what? We want to check the number of terms. Okay, so here if you see in this function, that is F1 and F2, there are three variables. So what are the three variables? One is A, another is B, and another is C. So there are totally three variables are available. Whether A or A dash, that will be called as a single variable only. Similarly B or B dash, that will be called as one single variable. Similarly C or C dash, that will be called as another single variable. Okay, this is the first checking the number of variables. And second thing is the number of terms. So each expression, if you see, there will be one term. For example, AB is considered as one term, BC means that is one term, or A bar B is one term. So if you check in this expression, we have how many terms, such that number of terms without any repetition. That is more important point. Without any repetition. So without any repetition, we want to have the things. Okay, so if you see like that way, A bar is one term and ABC is other term, A bar B C bar is another term, A bar B already one is there. So already this is getting repeated. So we should not count this. So another thing is BC is another term and A bar C bar is another term. So totally if you see, without repetition I have around 5 terms. Okay, without repetition I have around 5 terms. Okay, so these two conditions, keep it in the mind. First you want to check how many variables. Second thing is how many number of terms are there without any repetition. Clear? So after this, how you can proceed? So first I will go with your PLA implementation, that is programmable array logic array. So as per the definition, we know that programmable logic array means both your AND array and your OR array are programmable. So this is the thing. So both your AND array and your OR array are programmable. Okay, so here I want to make programming both for your AND array as well as for the OR array. So how to proceed? First thing is the number of variables. Number of variables here how much? It is a 3 variable. So if there are 3 variables, first you draw 3 vertical lines. Okay, so I am going to draw 3 vertical lines for 3 variables. One is A, another is B, another is C. And draw the complement part for each variable. So this is for here A bar, and don't mistake me, I am using a pen, so I am not using any scale, so it will be somewhat the line will be somewhat slanting. Okay, so I have drawn A, B, C as well as the complement part. So this is nothing but your A bar, this is nothing but your B bar, and this is nothing but your C bar. Got it? Now what you want to do, so this part is over. Number of variables. Then next thing is number of terms. So totally there are 5 terms. So if there are 5 terms, what you want to do? You want to draw 5 horizontal lines. Okay, 1, 2, 3, 4, 5. Okay, I have drawn 5 horizontal lines. Okay, and each horizontal line should be ended with one AND gate. Okay, each horizontal line should be ended with one AND gate. So I am connecting an AND gate at the end of this horizontal line. I am connecting on AND gate at the end of this horizontal line. Okay, so there are 5 terms. I have connected 5 AND gates in a horizontal fashion. Then you fix the each and every term. So first term is what? A bar B. Okay, first term is A bar B. Second term is what? A B C. And third term is A bar B C bar. And fourth term is B C. Without repetition I am writing. And fifth term is A bar C bar. Okay, fifth term is A bar C bar. Now what you want to do? A bar B means what? You want to make a program. A is programmed, A bar is programmed, and B bar is programmed. So this will produce A bar B. Second one, A B C. So A is programmed, B is programmed, and C is programmed. So wherever that is programmed, I am making in a cross mark. Similarly, next one is A bar B C. So this is A bar, this is B, then next thing is C bar. A bar B C bar. And next thing is BC. So this is your B terminal and this is your C terminal. The next thing is A bar C bar. So this is your A bar, this is your C bar. So now we have made us your AND gate as programmable. Already we know that if it is PLA, both your AND and OR array should be programmable. Now AND array we have made programmable. Now we want to make OR array also as programmable. So how to make your OR array as programmable? Now we want to check the number of outputs. So here how many outputs are there? I have 2 outputs. One output is F1, another output is F2. So what we are doing? So once again I am going to extend this line. Okay, once again just I am going to extend this line and I am making 2 vertical lines. I am making 2 vertical lines. One is connected to one OR gate which is your F1 and another is connected to another one the OR gate that is F2. Okay, so 2 OR gates are now getting connected. Now you want to make a connection, that is you want to make your OR gate also as programmable. How you will make the OR gate as programmable? For F1 the terms 1, 2, 3 are getting connected because this is your first term, this is your second term and this is your third term. So what I am going to do, I am making connection for your first 1, 2, 3 terms, and for your second one you have your A bar B and 4 and 5th term. So A bar B where you are giving, here I have your A bar B and your 4th term and 5th term are connected. So now if you see AND gates are also programmed at this point. Here if you see OR gate also getting programmed. Okay, so this is nothing but what? The structure for your PLA, that is programmable logic device. Okay, is it clear how to draw the circuit using PLA logic? Okay, this is the logic diagram using programmable logic array concept. Programmable logic array concept. So the same concept now we will proceed for the next part. That is, what is the next part? That is how to implement the same thing using PAL, that is programmable array logic. So programmable array logic, what is the difference? Both are one and the same. In the programmable logic array, both your AND gate and OR gate are programmable. But in the programmable array logic, only your AND gate is programmable, whereas your OR gate is fixed. Which means that in this circuit, if you see in this circuit, okay, if I see in this circuit, this part, okay, this part is now here it is programmable, and here if you see this part with respect to here AND gate, this part is also programmable. Okay, so now what we are going to do, this part, that is this programmable part, that is AND gate part, we are keeping as such, because already we know that in the AND gate, in the PAL also your AND gate is programmable. So what you will do, this part we will keep as such. So this part we will keep as such. But OR gate, it is a fixed gate. But what is here happening? It is becoming programmable. So we cannot use this particular part. So this part alone we want to change it. Okay, this part alone we want to change it. So how to change this part alone? Okay, so what you will do? So once again repeat this diagram up to this first part. Okay, up to this first part, repeat it. So how I am going to repeat it? As usual, for PAL also I am drawing 3 vertical lines. One is for your A. Okay, this is for your A, which is having a complement part, and another is for here on the B, and another is for here C term. Okay, A, B, C, and this will be your A bar, B bar, and C bar. Okay, and there are 5 terms already we have seen. So draw 5 vertical lines. 1, 2, 3, 4, and 5. Okay, so and I have drawn 5 vertical lines. So first vertical line is for what? A bar B. Okay, so I am connecting this to AND gate. So this is also connected to one AND gate. This is also connected to one AND gate. This is also connected to one AND gate. So this is A bar B, first one. Second one is what? A B C. Yeah. Okay, so this will be A B C, and third one is A bar B C bar. A bar B C bar, and fourth one is B C, and fifth one is A bar C bar, A bar C bar. Okay, so you want to make a connection because this is programmable, that is AND array is programmable. So what you will do, A bar B, and next thing is A B and C. Next one is A bar B C bar. The next one is B C. The next one is A bar C bar. So up to this, whatever we have done previously, the same thing only. Now what is the change here is only OR gate is fixed. So OR gate is fixed, which is based on your output. So previously what we have done, you have just extend the line and you have made 2 vertical lines for your OR gate. That is for the 2 OR gates 1 and 2. But now what you want to do is, based on your equation, I want to make this that is A bar B, A B C, A bar B C bar, all the things combined in a single OR gate, which is producing an output of F1. Okay, so what I am going to do, I am going to connect all the 3 things, okay, all the 3 things in a single OR gate, which is going to produce your output as F1. Okay, and similarly for your F2, A bar B is there. Okay, so A bar B is there. So what we are going to do is, from this and the A bar B, I am taking one lead. Okay, so along with this A bar B, already we have here BC and A bar C. This is also connected to a fixed another OR gate, which is here F2. Okay, so this is connected to the OR gate number 1 F1, R2 is connected to here, F2 is connected to here OR gate number 2 F2. Okay, see here if you analyze, so this is nothing but what? Programmable. So your AND array is programmable. But here if you see, this is your OR array. Okay, so OR array I am not going to program, and it is in a fixed nature. Okay, so OR array is in fixed nature, whereas your AND array is in programmable nature. So whereas your AND array is in programmable nature. So this is how we are implementing this particular any logic using PAL or PLA. Okay, so now here we have given directly the expressions. Here I have given directly the expressions. So if you are not given with any output expression, if I am given like this way, for example, I am given with one x is for example x of a comma b comma c is summation of 2 3 5 7 and y is something like how we can write y is a comma b comma c. This is summation of 0 1 and 5 and z of a comma b comma c is nothing but summation of 0 to 3 and 5, 0 to 3 5. Okay, now there are three outputs. One output is your x, another output is y, another output is z. But here the output expression is not given. It is given in the term of SOP form. So you want to write and then you want to reduce that into sum of min terms. So how you will reduce it into sum of min terms? One way is that is x equal to, they have given summation of 2 3 5 7. So this one how we can write? One way is that is 0 1 0. This can be written as, because it is a 3 variable function. So 0 1 1 1 0 1 and 1 1 1. So this will be written as a bar b c bar plus a bar b c plus a b bar c plus a b c. So this is one way of writing. But once again what you want to do? You want to simplify this expression and you want to reduce that expression. Okay, but instead of going for this reduction, we can simply reduce it using your K-map. Already we know Karnaugh map reduction. So since it is a 3 variable Karnaugh map, I am drawing a 2 cross 4 matrix. Okay, I am drawing a 2 cross 4 matrix where you numbering is 0 1 2 3 4 5 6 7. Okay, and here the variable will be, for example, they are given as ABC. So this will be ABC. A can take either 0 or 1. BC can be either 0 0 0 1 1 1 and 1 0. Okay, so the first term they are given as 2 3 5 7. So where the output is 1 2 3 5 7. So when you group this, what you will do? So this is one pair and this is another pair. So for this pair, what is the answer? This pair, the answer will be A bar, the common term is B. And for this pair, the answer will be what? For this the pair, the answer will be A. Here the common term is C. Okay, here the common term is C. So your output expression for your x is what? A bar B plus AC. Okay, similarly, I want to simplify for your y term also. So how you will simplify for your on the y term? Apply the same logic. Okay, applying the same logic. So here 0 1 5. So 0 1 5 means this is 0 term, 1th term and 5th term. So here if you see, there will be two pairs will be, you can find out. Okay, this is 0 1 5. So two pairs. Okay, if you are unable to understand, I will write in a brief manner. This will be 2. So this is 4 5 7 6. So for this term, the answer will be A bar. The common thing is B bar. Okay, common term here is B bar. Okay, common term here is B bar, A bar, B bar. And for this the common term will be B bar C. So your y term is nothing but A bar B bar plus B bar C. Okay, A bar B bar plus A bar B bar plus B bar C. Now we will go for the next term, that is 0 to 3 5. Okay, your Z is 0 to 3 5. Okay, so for the Z term also I am going to draw your K-map. So it is also a 3 variable K-map where I am numbering as 0 1 2 3 4 5 6 7. This is A, this is BC. BC can take the value from 0 1, now 0 2 3 5. Okay, 0 3 to 5. So how will you group this? So this is one pair and this is another pair, two pairs, and this one is single. Okay, so when I talk about this pair is nothing but what? A bar, and these two things common term is C bar. And when I talk about this pair, your common term is A bar. In these two things common term is B. When I talk about this single, so this single comes in the category of A, B bar, C. So your output expression Z is nothing but A bar B plus A bar B plus this is what? B C, correct only. Okay, A bar C bar, and the next thing is A B bar C. Okay, so already we have find out what is your Y. Y is nothing but what? A bar B bar plus B bar C. And what is your in the X term? X term already I have written here. Okay, that is A bar B plus AC. Okay, so that's all. Now we want to check how many terms are there, how many variables are here. First of all, there are three variables. What are they? A, B and C. There are three variables are there. And how many terms are there? When you talk about the terms, A bar B, so this is one term. AC, this is your second term. Okay, A bar B bar, this is your third term, and this will be your fourth term, that is B bar C. And A bar B already repeated, and A bar C bar, this is your fifth term, and A B bar C, this will be your sixth term. Clear? So this will be your sixth term. So what you will do? First draw the things for three things, that is draw for variables. One is your A, B, C. So this will be for your A bar, and next thing for your and the B bar, and next thing for your C bar. And we have seen that there are 6 variables. So 6 vertical lines, 1, 2, 3, 4, 5, 6, and each vertical line is connected with one AND gate. So each vertical line is going to get connected with one AND gate. Okay, and what is the output for your AND gate? First term is what? A bar B. Okay, A bar B. Second term is AC, and third term is A bar B bar. A bar B bar. Fourth term is B bar C. B bar C. Fifth term is A bar C bar. A bar C bar. And sixth term is A B bar C. A B bar C. Clear? So okay. Now A bar B we want to connect it. So this is your A bar, this is your B. Next thing is AC. A I want to connect, C I want to connect. Then A bar B bar. A bar and B bar. Then B bar C. This is your B bar, this is your C. Then A bar C bar. This is your A bar and this is your C bar. So please understand that this is nothing but my A bar, nothing but my B bar, this is nothing but my C bar, because I have taken through an inverter. And next thing is A B bar C. Clear? And for the first variable, what is the thing? X is A bar B plus AC. So X is A bar C. But here we are first thing we are implementing using PAL, that is PLA. So what I told you, you just extend this line. Since we are having 3 outputs, just I am going to extend this, and for 3 outputs I am going to draw 3 vertical lines. Okay, each vertical line is given with one OR gate. Okay, I am going to given with one OR gate. First output is X, second output is Y, third one is Z. So first one is what? First 2 terms, that is A bar B and AC. Second one what? A bar B bar plus B bar C. A bar B bar plus B bar C. Okay, and third one is what? A bar B, that is A bar B, then A bar C plus A bar B. Clear? So now we have, based on the expression, now I have designed this PLA. Clear? Now based on your expression, now we have designed this PLA. Now if the same question, how to implement using PAL. Okay, how to implement using PAL. Like already I have told you, what you want to do is just to replicate this particular concept. Okay, so I will go with some other on the color so that it will be easy for you to understand. Okay, so what I am going to do is I will be replicating the same part. Okay, so I will be replicating the for 3 variables. Now I am going with here PAL concept. Okay, I am going to replicate with here PAL on the concept. So for here A, B and C. Okay, A, B, C I am replicating. So as usual same thing. We have how many terms we got here? Around 6 terms. So 6 horizontal lines. 1, 2, 3, 4, 5, 6. 6 horizontal lines, and output here is A bar B. This output is AC, A bar B bar, A bar B bar. Next one is B bar C, B bar C. Next one is A bar C bar, A bar C bar, and finally A B bar C. So you connect as such, that is A bar B. So this is your A bar, this is your B bar, this is your C bar. So first one should be connected with the A bar B, second one should be connected with the your A C, third one should be connected with the your A bar B bar, fourth one should be connected with the your B bar C, fifth one should be A bar C bar, and once again this should be A, B bar and C. Okay, so this is the thing. So next thing what you want to do, I want to make a connection using PAL. So this is now made programmable. So now AND gate is programmable. We want to go with your OR gate. So OR gate, how you will do? For your X expression, already we have known that X expression is first 2 terms of OR gate. So what I am going to do is, I am going to take these 2 inputs, okay, and I am going to connect this to one OR gate for your X. And the second expression, if you see, A bar B bar plus B bar C, that is for your second output. So I am taking these 2 things, and it is going to connect to one more OR gate. This is your Y. And third one, if you see, it is also having A bar B and last 2 terms. Okay, so A bar B. So what you will do, if you want have a connection like this way also, again and make a connection. So this one and this one, all the 3 I am going to connect with here Z term. Okay, so here if you see, this is completely fixed in nature, that is here R array is fixed in nature, and in your AND array, if you see, this AND array is programmable nature. So this concept is nothing but programmable array logic. Clear? So now I think all of you may clear with how to implement any circuit or any expression, whatever that is given to you, using PAL or PLA. Okay, so first thing what you want to do, you want to check how many variables are there So based on the number of variables, first draw your vertical lines and draw the corresponding complement part also for it. Then based on the number of terms, draw the horizontal lines connected with your AND gate. Okay, and whether it is PAL or PLA, based on that implement it. Okay, so I thank you once again all for your patient listening.